Imagine you're given a question like this. The question said, when a 20-volt EMF is placed across two resistors in series, a current of 2 amp is present in each of the resistors. When the same EMF is placed across the same two resistors in parallel, the current through the EMF is 10 amp. What is the magnitude of the greater resistance? What is the magnitude of greater of the two resistors? So here we have a two separate question. We are given EMF, okay, and a current for resistors in series. So we have that, and for resistor in series, the equivalent resistance, let's say R total, or the total resistance is R1 plus R2. And we are given the EMF, and as well we're given current. So we have that V is equal to IR, right? And R is equal to V over R. So this implies that we have V to be 20 and the current, so this should be current, the current to be 2. So I have my equivalent resistor to be 10 ohms. Okay, so in this case I can say that this expression will be 10 is equal to R1 plus R2. This for resistor in series. So in the second case, we're told that the same EMF was actually placed in two resistors across two resistors in parallel, but this time the current is 20 amps. Let's see how we can approach this as well. For resistor in parallel, we have that the equivalent resistor that is equal to 1 over R1 plus 1 over R2, and we use the same formula, this very one, R equal to V over I, and from the question we were told the same EMF and the current will be 10 amps. So this implies that V over I, which is equal to 20 divided by 10, and this is equal to 1 over R, this is equal to 2, and this is R total to, this is the equivalent resistance in parallel, right? So if we decide to substitute these two in this equation, we'll be having 1 over 2 is equal to 1 over R1 plus 1 over R2. This is the relationship between the two resistors in parallel. So I have this to be equation 1 and I have this to be equation 2. From this equation 1 we can write it in terms of R1, and I can say that R2 is equal to 10 minus R1. So let me take this as my equation 3. If I decide to substitute equation 3 in 2, then I'll be having this expression. This is 1 divided by 2 is equal to 1 over R1 plus 10 minus R1. Yeah. 1 divided by 10 minus R1, and to simplify this, we can decide to multiply both sides by this expression R into R1 into 10 minus R1. If I multiply through, I'll be having R1 into 10 minus R1 divided by 2 is equal to 10 minus R1, because the R1 will cancel R1, plus R1. Then 10 minus R1 will cancel this. So at this point, I can see that the R1 and cancel themselves, and I'll be having R1 into 10 minus R1 divided by 2 is equal to 20, and is equal to 10 rather, and this is equal to R1 into 10 minus R1 is equal to 20. So if I open the bracket, I'll be having 10R1 minus R1 square is equal to 20, and this will be equal to R1 square minus 10R1 plus 20 is equal to 0, and this is a quadratic expression. So using the formula methods to solve for R1, we have that the R1 will be equal to minus B plus or minus the square root of B square minus 4AC divided by 2A. So, and this is A, the coefficient of R square is A, the coefficient of R1 here is B, and this will be C. So substituting it in this expression, we have that R1 is equal to negative 10 plus or minus the square root of B square is minus 10 square minus 4 multiplied by A is 1, multiplied by C is 20. So divided by 2 multiplied by 1. And if we decide to simplify further, then we have that R1 will be equal to 10 plus or minus the square root of 10 square will be 100, and this will be negative 80 minus 80 4 divided by 2. And if I decide to simplify for that as well, I'll be having this expression 20 divided by 2. And if I use my calculator, then the square root of 20 is approximately, the square root of 20 is approximately 4.47. So if I use that in place of square root of 20, I'll be having that my R1 is equal to 10 plus or minus 4.47 divided by 2. And that means the R1 will be equal to 10 plus 4.47 divided by 2, or 10 minus 4.47 divided by 2. So I will solve two of them simultaneously. So this means that this is 10 plus this will be 14.47 divided by 2, and 10 minus 4.47 will be 5.53 divided by 2. And that means this expression will be 7.24 and ohms, and 5 and 2.76 ohms. So we're asked to find, let's go back to the question again. So we're asked to find what's the magnitude of the greater of the two resistors. So based on the answers we got, we can testify that the greater one is 7 point. This 7.24. So going back to the option, then we can see that option A is the right answer. Option A is the right answer. So thank you for watching this video, and if you like this video, kindly subscribe to the channel for more updates.